be looking at it the whole time. I just kind of
Understandable. The vertex here, if you know the formula for parabola in vertex form, vertex is h comma k. So here the vertex is 4 comma negative 3. Do you know if this is multiple choice or is it worked out questions?
I feel like this is going to be like multiple choice.
Okay.
Wait, could you scroll up to number 6 again, please?
Sure.
Thank you. All right, so we got ax minus h squared plus k.
Mhm.
Vertex is 4. Oh, okay. I remember this. All right, now write the equation of the parabola in vertex form by completing the square.
That's why I asked. You don't have to complete the square. You just have to know how to find the vertex, which is from formulas. Like this is ax squared plus bx plus c. The x corner of the vertex is minus b over 2a. And the reason you would do this is rather than completing the square. So this is minus 14 over 2 times 1. 14 over 2, which is 7.
Oh, and then you plug it back in, and then you get 7. 7 times 7 squared minus 14 times 7 plus 1,
right?
Which is 49 times 7, which is like, oh wait, no, I don't have the right idea. Never mind.
Yeah, so you end up getting a minus 48 here. So the reason this is useful is you can write y equals a x minus h squared plus k. Your a is the same as this a. They're the same.
Okay.
Which is 1. So it's 1x minus 7 squared minus 48. You can complete the square to get that, but it's usually better to use formulas. And if it's multiple choice, you can just look at it and figure out which one looks kind of right to your eye.
All right, makes sense.
Number 8 is to solve using the quadratic formula. So we know that a equals 3, b equals minus 2, and c equals 5. And we have x equals opposite of b plus or minus the square root b squared minus 4ac all over 2a minus minus 2 plus or minus the square root of b squared minus 2 squared minus 4 times 3 times 5 all over 2 times 3. This should all look super familiar to you. It's nothing new. You've seen this in plenty of other classes. So the inside part here, inside the square root, it's the square root of 4 minus 60, which is the square root of negative 56.
All over 6.
So the square root of 56 breaks apart into 2 and 28, 2 and 14, 2 and 7. So some 2's come out. You get 2 plus or minus 2i squared root of 14 all over 6. Divide both of these by 6. So you get 1/3 plus or minus I squared root of 14 over 3. Those are your 2 answers for that.
Fair enough.
Okay, number 9. What is the degree of the polynomial? So when you're looking at this graph, the degree of the polynomial, you can make a guess here, but you really need to identify the turning points. There's 1, there's 2, and there's 3. So we got 3 turning points, or 3 TPs, and the degree is equal to the number of turning points plus 1. So in your case, it's 3 plus 1, which equals 4. That's it. Nothing else.
Oh, it's just the degree?
Yep.
All right. And turning points are those. Wait, so how come you add them up again?
Why do you add them?
Mm-hmm.
I mean, this is just a known thing. This is like a fundamental theorem of algebra.
Oh, degree equals turning point plus 1. All right, that's smart. All right.
State the degree of the polynomial. You have to look for the highest degree term, which is this one. which is the highest degree. It doesn't have to be the first one, though it should be written that way, but it's not. So the degree is 5. It's the exponent.
It's just that. That's the whole problem, basically.
That's it. Nothing more to do.
All right, on the number 11.
Sometimes you can try to do more than what is needed, and that's kind of what I was hearing there. Is the point on the graph right there a relative max, relative min, absolute max, or absolute min? So they're kind of not telling you that these go up and down forever. They should. So there is no absolute max and there is no absolute min, because when it goes up forever and down forever, there's none of that. This point here, though, compared to those places around it, is it higher or smaller than those places around it? Well, it's higher. That's why it's a relative max. This down here, if it was pointing to that, that would be a relative min.
Oh yeah, because it's going
But that is
below. All right.
That's a relative max.
Maximum.
It says to divide. What's not clear to me is whether we can just use synthetic division. I don't know what to tell you. Or you got to do it by hand. Exponent. That's why I keep asking, is it multiple choice or not? Because it makes a difference with how you solve it. So we got to do one long division, one polynomial, or one synthetic division. So here it's going to be 3x, because 3x times x gives you the 3x squared minus 3x. I'm just multiplying 3x by each of these, and then you change the sign of both of them. That's kind of key here. That gives you that the first one goes away, plus 4, and then you try to figure out what do you put here so that you get an x down here. What's plus 1? 1 times x is x. 1 times minus 1 is minus 1. Change the sign again of both. You get 5. So that's your remainder. So there's your quotient, your remainder, and your divisor, and you write it as quotient plus remainder over divisor. Your quotient is 3x plus 1. Your remainder is 5, and your divisor is x minus 1. So this is what it's looking for as a final answer.
That's straightforward.
Yes.
On to the next.
Yeah, so for the next one, we'll use synthetic division. Okay, so with synthetic division, we're going to put 4 in the box because 4 is what makes the bottom 0. And then you put the coefficients here. Okay, and then you bring the first one down. So bring the 3 down. 3 times 4 is 12. Okay, 10 down here. 10 times 4 is 40. Wow, this is getting big. 44 times 4 is 176. So this last number here is your remainder.
All right.
And this was an x cubed, but it goes down by 1 degree. So it's 3x squared plus 10x plus 44 plus 175 over x minus 4.
All right. On to number 14.
Yep. Find the vertical and horizontal asymptotes of the function. So the vertical asymptotes are where the bottom equals 0. So in this case, where does x plus 2 equal 0? When x equals minus 2. That's your vertical asymptote. The horizontal asymptote, because they have the same degree, these have the same degree in this problem. It's the ratio of the leading term. So the leading term here, if we rewrite this, it's really minus x plus 3 over x plus 2. The leading terms is minus 1 over 1. And we write that as an equation, y equals minus 1 over 1, or y equals minus 1.
All right.
All right, so for 15, 15 has got some similarities. For the vertical asymptotes, you're still going to set the bottom equal to 0. You're still going to set x squared minus 81 equal to 0. There are two solutions to that. X ends up equaling plus or minus 9. So there's two vertical asymptotes. This time, though, for the horizontal asymptote, the degree of the numerator is less than the degree of the denominator. The degree of the numerator is 1. The degree of the denominator is 2. 1 is less than 2. When this is the case, it is always y equals 0.
Understandable.
All right, so let's go to the graph here. Okay, so to graph this, you're going to do many of the same things we just did. You have to first find the vertical asymptote, which is where x minus 3 equals 0, or at x equals 3. So I'm going to draw a vertical line at x equals 3. You then need to find the horizontal asymptote. This number in this form is the horizontal asymptote, y equals 4. 1, 2, 3, 4. Okay. And from here, to me, it's enough. You could just sort of draw in the graph here.
Yeah.
You would need to do a lot more here to find like the x-intercept or the y-intercept or so on. But that's usually good enough. You said you got the solution thing here. You did send me that. If you're looking at it, I mean, just tell me if you're seeing something. I mean, yeah, the instructor basically sent you this. They got the answers, not the solutions. Why do they try to get all these on one page? Wow. Okay, that's weird. Okay, 17 now. The slant asymptote is another way of saying divide the polynomials. So how do you want to divide these? Do you want to use synthetic division, or do you want us to use long division?
I want to try synthetic division.
All right, so 2 goes in the box, and then you got 3 minus 4 and 1. Bring the 3 down. 6, 2 times 2 is 4, 5. So you have a remainder here. Remainder is not important. This right over here, this 3x plus 2, your quotient is the slant asymptote. So that is y equals 3x plus 2. It's this part down here.
Oh, okay.
All right, 18. 18 says to simplify, what you really need to do is you need to factor the numerator, and then you need to factor the denominator. So that's x minus 3, x minus 2 over x plus 4, x minus 2. You cancel out the terms that match, and then you just rewrite it here. And you're done.
All right. On number 19.
All right, so solving. These problems lead really well into each other because the thing you did on the previous one has to be done here. Like you have to factor this right-hand side here. And you have to then recognize what x cannot be. X cannot be -1 or 9 because you end up dividing by 0, which is not allowed. So on the left here, you have to recognize that, well, each of these is missing something. Like the x plus 1 doesn't have the x minus 9. So you're going to multiply top and bottom by x minus 9. Minus 3 over x minus 9, well, that's missing an x plus 1. Equals 2 over x minus 9 x plus 1. So the nice thing here is that you only have to look at the top, not the bottom, because the bottom is the same everywhere. You've already handled the fact that what it can't be. So you just look at the top. So it's 2 times x minus 9 minus 3 times x plus 1 equals 2. 2x minus 18 minus 3x minus 3 equals 2. So you get negative x minus 21 equals 2. When you move some things around here, you end up getting that x is equal to minus 23. I guess.
All right.
I don't know. Is that the right answer? Yeah, it is. Okay. 20. Write the expression in radical form. This is where I worry that, like, if you get the like the backwards of this, like, it might not be clear what to do. This is the 6th root of x to the 5th, and so, like, I know to put that number there, I know to put that number there, but you could very easily get the question that says write the radical in or write the radical with just an exponent, and you have to go backwards. But this is it. There's nothing more to do here.
Oh, okay. I see what. All right.
I mean, we're just doing what's on these pages. I mean, if you get 40 questions exactly like this, well, you're in good shape. Solve 3 equals minus 5 plus square root of 10 minus 2x. You need to isolate the root, which means that you're gonna move the 5 over to the other side of the equation. So you're gonna add 5, 8 equals square root 10 minus 2x. Then you're gonna square both sides. 64 equals 10 minus 2x. And you're going to move some things around. You get 2x equals minus 54, x equals minus 27 when you're done solving that.
X equals all right. Just got it.
I know I'm going pretty fast, and I know there's the recording, you got the notes here. I think we'll get through all of it. That's kind of I see how many there are. We can probably just make it if we keep going at this speed. So
All right. All right. So x plus 5, square both sides.
Square both sides.
3x minus 3 equals x plus 5.
Yes.
Minus x plus 3 plus 3. 2x equals 8, x equals 4. All right. Under 23.
23. So this one is kind of like 21, where you have to isolate the root. In this case, it's a cube root. You have to know to add 2 to both sides first. So you get the cube root of 3x minus 5 equals 3. And then you still have this negative 3 out in front, so you're going to divide both sides by negative 3. So you get the cube root of 3x minus 5 equals negative 1. And then now you cube both sides. So you get 3x minus 5 equals negative 1. Add 5 to both sides. 3x equals 4. X equals 4/3.
3x minus 5 equals negative 1. All right. X equals 4/3.
Oh, they do give you they give you the question I just mentioned there in 24. It's going the other way. So it's I don't know, it's x to the 2/3. You have to know that 2 goes there, and then 3 goes there.
Oh, all right. All right. Is that all?
Yeah, there's nothing more to do there.
On to number 25, I guess.
Describe the transformations that occurred. So there are 3 transformations in my view. The minus 3, x minus 3 means you went right 3. The plus 5 means you went up 5. And the 2 is a vertical stretch by a factor of 2.
Makes sense. All All right, number 26.
26. You got to undo a cube root, which is what 1/3 power means. 1/3 power is cube root. So the cube root is, or the x plus 2, 1/3 power, equals 2 cubes. You end up getting x plus 2 equals 8. So you get x equals 6. Is your answer.
It's actually that simple.
Yes. 27. Okay, 27's got a little bit more to it, and 28's got a little wrinkle to it as well. All right, so you still want to square both sides to get rid of that square root. On the left, it just becomes 3x plus 1, but on the right, you have to remember that this is x minus 2 times x minus 2. It is not something else that is completely wrong, because this is a common mistake. You get x squared minus 4x plus 4. You need to move everything to the right this time, because you really want x squared to be the positive one, so minus 7x.
X squared minus 7x plus 3.
So that doesn't factor, and
That's quadratic formula.
yeah, and I'm like surprised. I'm really surprised. So anyway, it's 7 plus or minus the square root of 49 minus 4 times 1 times 3 all over 2 times 1.
49 minus 12 is, what is it? 37?
Yeah. So you end up getting that. I'm a little surprised.
7 halves plus or minus 1/2. All right, root 37. All right, on to number 28.
Okay. Yeah, so this one, it's important to rewrite this one in can't think of the word, radical form. So it's the cube root of x squared equals 4. If you don't do this, you will miss one of the solutions. And you might not be sure how that is or why that's true, but I mean, I assure you that like this is classic kind of thing here. So to undo the cube, you cube both sides, you get x squared equals 64. So x equals plus or minus 8. The mistake is trying to undo the 2/3 power in one step. Like go to the 3/2 power, because then you get x equals 8, but you miss the negative 8.
Oh, you keep. So that's the mistake.
Yes.
All right. Let's go to number 29.
29. Find the inverse of. So the inverse means to swap, exchange x for y. So first data point becomes 2, 1. Next one becomes minus 4, comma 2. 0, comma minus 1. Minus 1, comma minus 5.
Oh, you just switch them, right?
Yep.
2, 1, 4, negative 4, 2. Negative 1, negative 1, 5, negative 5. All right, on to 30.
So the inverse is of a function. You first have to write f of x as y equals x cubed minus 2. Then, this is key, you switch x and y, which is what we just did in the previous problem. And now you have to solve for y. You have to solve for y. So it's a few steps here. Y equals the cube root of x plus 2.
Mm-hmm.
This one's not super sophisticated, but could get some that are a little bit more effort to do them. All right, on to 31. So 31 says, is this growth or decay? It is growth because the number inside here is greater than 1.
All right. This one looks like this would be growth, right? Because it's more than 1.
Yes, yes. I'm trying to lead you. I'm not leading you to water here. You know, like
Yeah.
not trying to. So like I could give you decay. Here's a decay.
Plus than 1, so it'd be like negative
Like
or a fraction.
3/4 x. Yeah.
All right. Sounds good. Let's go to number 32.
32. What do you say? I mean, this is.
For number 32?
Yeah. What do you say? I mean, well, you got the answer key. Maybe that's not fair. Okay, this is growth.
Oh, this was just decay.
This is decay. Yeah.
All right, 32 decay. All right, 33. Left one up to multiplied by a factor of 2.
Um,
The base 2 does that not do that?
you don't have to account for the base. Like
Oh,
what you
okay.
said, what you said would be true if there was another 2 out in front. The parent function is 2 to the x. So like you said, it's right 1 and then up 5.
All right, good. All right, on to 34. 3 to the 4x minus 6. This is just, that's weird. Yeah, it's just put 4x minus 6 equals 2x plus 4 minus 2x minus 2x plus 6 plus 6. 2x equals 10 divided by 2 divided by 2, x equals 5.
Yes.
And for 35, we got different numbers. I know that they have a base of 2. Is it like 2 to the 5th that gets 64?
2 to the 6 is 64. But Jack, let me interrupt you here because you can actually get 64 as 4 to the 3rd.
Oh, you can?
And that already matches the base there. Like you can make them both go to the same base, but it's really not.
Except for stuff that you don't need.
I'm trying. It's like it's a shortcut, I guess.
Let's go on to number 36. Solve for log base 3 of 2x plus 5 equals 2.
Right. So you can rewrite this into an exponent, or you can undo the log with base of 3. So remember I showed you 3 to the log base 3 of 2x plus 5 equals 3 squared. These 3's have to match. On the left, these cancel, so it just becomes 2x plus 5 equals 8.
And
I'm sorry, 9. I just wrote the wrong thing. And so 2x equals 4 and x equals 2. The alternative way to do this is to just immediately rewrite it as 3 squared equals 2x plus 5, which is, if you remember, you go back and forth between exponent and log form.
Yeah.
And it's the same solution. You get the exact same thing. You just do it slightly differently.
Understandable. On to number 37. Let's see. Condense this.
Condense.
5 log base 3 of x minus 2 log base 3 of y.
So the first thing you want to do, as you'll see me do here, is you want to move those numbers out in front, from out in
Right
front
to the right.
to the exponent, yeah. And then the next step, you're using log A minus log B equals log A over B. So this becomes a single log with, because
Log
the first
B.
one's positive, it goes in the top. Because the second one is negative, it goes in the bottom.
Oh, they're the powers. Okay.
Yes.
Y squared. All right. That's relatively simple.
Yep.
Let's go on to number 38.
This is definitely a condensed form of like all the problems we've been doing. It's not as sophisticated. You should be in good shape to get a good grade here. So all this first one is log A over B equals log A minus log B. So you're going to take log base 4 of 5 minus log base 4 of 3.
You can just do log base 4 of what's it? Just 5 over 3, right?
Well, you're expanding. You're expanding. I mean, this is done. There's only one expansion step here.
Oh, never mind. You're expanding. I forgot about that. All right.
If you go back, you've just turned it into the original problem.
Okay. On number 39.
39. Rewrite in log form. So this is, it's akin to what we did earlier. It's log base 4 of 64 equals 3. It's like you have to know that that goes there, and that goes there, and that goes there. Because we went the other way in a couple problems ago. We went, if you look up here in 36, we went the other direction.
All right.
So
Number 40 is 5 cubed equals 125.
Yes.
Now 41. This is the stuff I usually get confused with because of the different formulas.
So the first one does not say continuous, does it?
No, just semi-annually.
That's right. If it said continuous, you would use PERT. Because it is not continuous, you're going to use the P1 plus R over N to the N times T power. The principal in this case is 500. The interest rate is 0.045. Semi-annually means N equals 2. And then 4 years. So you're just going to plug this into your calculator and you're going to get, well, we've got the answer. But I would make sure you can plug it into your calculator because it's
pretty long.
You want to make sure you can do this because you won't have the answer key when you're taking the test.
I got 597.42.
Yep.
All right. Last one, number 42.
So this one is continuous. And how do you know that? Well, it says it. Like it says one will say continuous and one will not. And that's how you remember this. There's nothing else that needs to be said. Like we're not going to make it any more complicated than that. It is a different formula. A equals PE to the RT. So your principal is $1,500. Your rate is 0.032, and that's for 8 years.
I get 1937.63.
Yeah.
I think that was everything I wanted to go over, Matthew. Thank you very much.
Excellent. Excellent. You're in great shape, and I appreciate you scheduling, and I'll see you next year, I guess.
I appreciate it.
You're welcome. Bye now. Bye.